Around 12,000 years ago, humanity faced a new set of pressures. Transitioning from hunting to farming meant managing resources with a level of precision that wandering groups never required. Mathematics emerged as a vital survival tool for this settled way of life. Imagine you are a village shepherd in 7000 BCE. You need to ensure every member of your flock returns to the pen at night, but your language has no words for numbers. Without the concept of 50, you have no way to speak the size of your herd. This animation shows a workaround called one-to-one correspondence. For every sheep that leaves the pen in the morning, you drop one pebble into a leather pouch. When the flock returns, you remove one pebble for each sheep. If a pebble remains in the pouch, a wolf likely took a sheep during the day. As villages grew, counting identical pebbles wasn't enough to track different types of property. This led to the clay token system. A small cone represented a specific measure of grain, while a flat disc represented a single sheep. These 3D shapes allowed farmers to categorize and store their wealth as data. At this stage, counting remained concrete. The quantity was inseparable from the physical object. You couldn't think of 3 as an independent idea. It only existed as 3 sheep or 3 jars of oil. To protect these records during long-distance trade, merchants invented the bulla. They placed the clay tokens inside a hollow clay ball and baked it shut. This created a tamper-proof seal, ensuring the person receiving the delivery could break the envelope and verify that the count matched the goods delivered. Eventually, humanity moved past the physical object. They recognized that the quantity shared by 3 sheep and 3 thras of oil is the same. By stripping away the wool and the clay, they arrived at the number itself, a breakthrough called abstraction that allowed for the birth of true arithmetic. This grid highlights a spatial problem faced by early builders. As populations grew, people began packing into dense settlements. Most early shelters were round, but when you try to place round houses side by side, you create irregular gaps of wasted, unusable land. To maximize space, builders shifted to the rectilinear house. Designing with straight lines and 90-degree corners allowed homes to share walls and snap together. This created a highly efficient, zero-waste grid that could support a growing population. Archaeological sites like Çatalhöyük in Turkey provide a look at this early spatial planning. Dating back to 7000 BCE, these mud brick foundations show hundreds of homes built directly against one another, forming a single, continuous block of architecture. To guarantee these shared walls were perfectly straight, builders used a knotted rope to find a reliable right angle. By forming a triangle with sides of exactly 3, 4, and 5 units, they could create a 90-degree corner anywhere on the ground. They used similar rope and peg methods to draft massive, symmetrical stone structures. By driving a wooden peg into the center and walking the perimeter with a taut rope, a builder could draw a perfect geometric circle in the dirt. These methods were also used to divide farmland. To ensure fair distribution, early surveyors estimated the area of irregular plots by breaking them down into simple, manageable shapes, like rectangles and triangles. The practical need for dense housing and clear farmland boundaries turned the construction site into a laboratory. By mastering the right angle and the circle, these early builders established the foundations of geometry. While builders focused on the ground, the village farmer looked to the sky. In an agricultural society, timing is a matter of survival. Planting seeds just 2 weeks late could lead to a failed harvest and village-wide famine. To predict the seasons, farmers used horizon astronomy. They tracked the exact spots where the sun rose and set against the horizon throughout the year. By marking these shifting points, they could identify the solstices and equinoxes with high precision. For daily timekeeping, they used shadow reckoning. By placing a stick in the ground and measuring the length and direction of its shadow, they could track the hours of the day and the gradual change of the seasons. Early calendars were difficult to maintain. 12 lunar cycles add up to 354 days, falling 11 days short of the 365-day solar year. For a farmer timing a harvest, this discrepancy causes the calendar to drift out of sync with the seasons every year. To solve this mathematical mismatch, Neolithic societies built monumental stone observatories. These structures were engineered to function as permanent, physical calendars that anchored the community to the solar cycle. Stonehenge's massive stones are aligned so that on the summer solstice, the sun rises directly over the heel-stone, signaling the year's turning point. At Newgrange in Ireland, builders achieved even tighter precision. They constructed a specialized roof box above the entrance, situated so that for just 17 minutes on the winter solstice, a beam of sunlight travels the full length of the passage to illuminate the inner chamber. The shepherd, the builder, and the farmer used math to navigate the physical world. Their methods for counting goods, planning cities, and tracking the stars weren't abstract exercises. They were the life-saving tools that made modern civilization possible.